Hi, I suppose you already know how to set up Monogame. But just in case if you don't, I'll show you how I structured the project initially, so you don't have any questions. First off, I'm installing the Monogame templates from the .NET CLI. It'll make my IDE show my templates installed locally. After that, I'm running the writer IDE creating a new solution by clicking on the exec button. Selecting the cross-platform option, as I'm developing on Linux and also want to run the game on my Windows PC. After the project has been initialized, I'm switching on the file system mode in the left top corner, creating the src directory in which I'll store all the project code. And there, I create two subfolders yet, apps and libs. Apps is the entry point of my applications. It won't change. Hypothetically, it allows me to make different apps with the same code base, but it all depends on tools you use and many other things yet. Anyways, this is how I'm used to do it, and I feel it's better to do this way rather than not. I'm switching back to the solution mode to create exact solution folders as in the file system and put the project in the respect solution. As I want that it would be the same path as in the file system, I unload my project from the solution, move it in the apps folder, change the path to the project in the solution file, I load the project back. And just to make sure everything works perfectly, let's run it. We need to choose manually the running target now, clicking on the project select drop down button. This is the same duplicated one, selecting it with the green icon. Now click apply and run. Boom. From now on, we'll start bringing up an SAS library in our new project. So let's come a little bit closer. Which library I'm going to use? I was working with Entitas recently, but these and many other tools require you doing less or more extra work. The reason are code analysis, generation, etc., which to me seem redundant, so I'm gonna pick MARPath as this one of tools that meets my requirements. And by this, I also will migrate my game from Entitas to MARPath. But you can pick up whatever you want as well, must look at the principles, so specific language and tools shouldn't be an issue for you. First off, on a new game engine, we want to start off by creating a player which can move around as an alternative to Hello World and traditional programming. How do we do this using an SAS? Let's start with a brief overview of what SAS does and what it solves and why we need it. I hope you know about the Unity game engine. Basically, SAS can be compared to the workflow with monobehavior scripts, where a prefab is an entity and monobehaviors are components of the entity, but without a performing logic. So, how do these components work? They are handled by systems which exist globally, or seen by Unity terms, or in the world by SAS. Sounds easy, right? And it is. There are a lot of perks by using this approach. There is a picture of comparing OOP and SAS paradigms. There are a lot of useful resources to understand what it is deeper, and you better figure it out yourself. My goal is to show you how to start thinking in the SAS paradigm and wrap it up with some well examples, as to me, for a newbie with SAS, someday it was mostly hard to start coding this way than understand the logic behind it. Now, as we figure out what our workflow looks like, let's represent the project structure. So, after we've created a monogame project, I'm structuring it the way every piece of code is modular. Now we'll create a components project, entities project, and systems project. Those are separate layers, and only some of them should know about others without circular references. We're also splitting architecture in such explicit way as C# forbids cyclic dependencies. To help us ensure that these projects are loosely coupled in our code base, and we also want to write clean and maintainable code. In the future, we might change our infrastructure and we will, but not too much. So, for now, it could be a good point to start from. When we have our initial setup, let's call the algorithm. But before we do that, how do we move the player around? So, it might be either a gamepad, keyboard, or whatever. No matter what the device is, we receive an input from it, where the input interpreted as a value, which then we can work with. After we receive the input and got the value, we want to tell the player to move in the direction we expect. I guess it sounds easy at first, but if you're a newbie, it might be a tricky task for you, as there are so many details for such a simple feature. Trust me, it's so challenging only for the first time while you're learning. You'll crack the code, nail the game, and gain more knowledge to solve more challenging problems once. In my case, I write a 2D top-down game, so my input is similar to the XY graph axis, but y-flipped because none game has it that way, but don't mind it, as this changes nothing. If I press up, I move up on my screen. If I press right, I move right, and so on. My input values are relative to the axis and are in the range of 0 to 1. If I tell the player position to be equal to my input value, it will always stay in the range of a unit around. Not a huge area to hang around in it. So I have to move a unit forward relatively to the last position. Hence, I need to know my last position and assign the result of my last position plus the input value. And there is also a math problem with the vector values adding. We want to normalize the value because otherwise the player will move faster when he moves diagonally. Let's code. Now let's see. We received the input, we moved our player, two different actions, right? Right. It also might be so that I want to stop receiving my input values at some point to not move my player, for whatever reason. Collision, freeze effect, you tell me. What if I want to make the player jump in every step like a rabbit, or make it teleporting back if, let's say it's a fantastic game you want a glitch effect or sort of that? I don't want to read all that code and work with it here. I want another place for it. And, oh wait, is the input a part of the system movement? Should the movement system know about the details of how to move the player around? Of course not. But we were just setting up our architecture, so they will forget about the implementation itself if it's neither system nor any of the entities or components part. Do we need to start over again so it would fit in? No, this is the key. The code is loosely coupled now enough so we could easily just add and replace our modules in the future. Our systems don't have to know about how to perceive the movement, collisions, etc. They only need to know about what components they should affect and when. But to do that, those entities and systems would work. We need to provide them a place to live at. It could be a scene, right? But we call it a world in SAS. So let's initialize entities and systems in the world. Our implementation is a dependency of the system, so the system will run an implementation when it's needed and on who needs it. This is the power of ECS when code is segregated and clean code practices are followed. So we should split our system on smaller and introduce our implementations and receive them as dependencies to replace them easily without knowing any details, as their responsibilities should remain as simple as possible for the code maintenance. Well, this is called interface segregation. Hence, we'll want to control our dependencies from the highest point as possible, as we'd send a box down by elevator instead of demolition of the whole building. This is the responsibility of the dependency injection container, but it's a whole lot topic for another video. So we don't need to re-implement everything we've written before, but easily replace with the needed pieces of code. I would really love to see a rectangular moving around on my screen rather than numbers and letters in the terminal. Now let's actually write it all up and see how it works. Looks amazing. That's it. Hope it was helpful for you. See you in the next video.